All right, let's dive in. Today, we're going to tackle one of the heavy hitters in software design, the abstract factory pattern. We'll break down how this factory of factories helps you manage whole families of related objects, and then we'll get our hands dirty and actually build one in Go.
You know, this quote just cuts right to the heart of the matter. When you're building complex stuff, you have these groups of objects that absolutely must go together. Mixing and matching isn't just a little bug. It's a fundamentally broken experience for the user. And that is the exact problem that the abstract factory pattern was born to solve.
So, imagine you're building a UI framework. It needs to look and feel right on Windows, on a Mac, on Linux, everywhere. Now, your main application code, it shouldn't care what OS it's running on. And this is where a simple factory pattern starts to fall apart. See, you don't just need one button. You need a whole family of UI elements that all match. The button, the dialog box, the menu, they all have to look like they belong on that OS. That's the real challenge here.
And that leads us straight to the solution. You don't just need a factory for making buttons, you need something bigger, a higher level factory that hands you the correct set of factories for the job. You know, a Windows widget factory or a Mac OS widget factory. You need a factory of factories.
Okay, I know factory of factories sounds a little out there, right? A bit abstract. So let's bring this whole thing down to earth with a simple analogy that's going to make it all click.
I want you to picture a giant auto mall. When you walk inside, you don't just see a random jumble of cars. No way. You see a Ford dealership over here, a Toyota dealership over there, and a BMW dealership in the back. Each one is its own little factory, and it only produces its own brand.
And this right here, this is the core promise of the abstract factory pattern. The auto mall itself makes sure you never mix and match parts between brands. It guarantees what we call family consistency. You're never ever going to get a Toyota engine inside a Ford. That is the pattern's #1 job, to make sure you never create inconsistent families of objects.
And the way you use it, super simple. It's a two-step process. First, you decide which brand you want, Ford, Toyota, whatever, and you walk into that dealership. That's your first choice, picking the factory. Then, once you're inside, you pick the specific model you want. An SUV, a sedan, that's your second choice, picking the product. This two-level decision is absolutely key.
All right, with that auto mall analogy locked in our heads, let's see how we can translate this into actual Go code. We're going to build our solution around 3 fundamental pillars.
Pillar #1, the interfaces. Everything starts here. Just think of these as the blueprints or the contracts. We're going to define a base interface for what all vehicles can do, and then maybe some more specialized interfaces for specific types, like cars.
So here's what that looks like in Go. We've got a base vehicle interface. Anything that is a vehicle has to have, say, a getWheels method. Simple enough, but then we can layer on top of that with a more specialized car interface, which might also require a getDoors method. This layered approach is so powerful because it lets us treat everything as a generic vehicle if we want, but we can still get to those car-specific details when we need them.
Okay, pillar 2, the concrete factories. These are our dealerships. We'll have a car factory, a motorbike factory, and so on. Each one is responsible for one family of products and one family only. Their whole job is to enforce that family isolation we talked about.
And you can see that guarantee right in the code. Our car factory has a new vehicle method. And look at that return type, vehicle. Inside this function, it can only create things that fit that vehicle interface, like a luxury car or a family car. It is structurally impossible for this function to return a motorbike. That's the compiler enforcing our rules for us.
So this gets us to the absolute core mechanism that makes this pattern so flexible. It's this idea of having 2 distinct levels of choice, or what we call indirection. We're not just picking a product directly. We're picking a family first, and then picking a product from inside that family.
This 2-step process maps perfectly to our code. Step 1 is choosing the dealership. We call a function like buildFactory to get the family of objects we want. Step 2 is choosing the model. We then use that factory we just got to call a method like newVehicle to get the specific product we need.
And for our third and final pillar, we've got the actual products themselves, the real cars and motorbikes. And this is where Go's design makes this pattern just so clean and elegant, all thanks to something called implicit interfaces.
Check out this luxury car struct. It has a getDoors method, right? Well, that satisfies our car interface, and it has a getWheels method, which satisfies our vehicle interface.
The amazing thing in Go is that we don't need to write implements car or anything like that. If it has the right methods, it automatically satisfies the interface. This is huge. It means our product code is completely decoupled from the factories that create it. It's so clean.
Okay, so we've seen how to build it. We get the moving parts, but why would you go through all this trouble? Let's talk about a real-world example where this pattern is an absolute game changer. A perfect use case is abstracting away cloud providers. Think about it. You could have an AWS factory that makes S3 buckets and EC2 instances. Then you have a GCP factory that makes their equivalents, GCS buckets and compute engine VMs. Your main application code, it never knows or cares which cloud it's running on. It just asks the current factory for storage or compute. And the best part, if you want to switch from AWS to GCP, you don't touch your application code. You just change a single line in a config file at startup. That is incredibly powerful stuff.
Now, people often get this confused with the builder pattern, so let's clear that up real quick. Abstract Factory is all about product families and guaranteeing they don't get mixed up. Builder, on the other hand, is all about a complex, step-by-step construction process. They really solve different problems, but hey, sometimes you might even use them together. All right, we have covered a lot of ground. Let's boil it all down to the key things you absolutely need to remember.
First and foremost, if you remember nothing else, remember this. It's a factory of factories. It's a two-step dance. Get the right factory, then use that factory to get the right product. Simple as that.
Takeaway number 2, and honestly, this is the big one. The whole reason to use this pattern is for its core guarantee, family consistency. Your car factory will never, ever create a motorbike. This wipes out an entire class of really nasty bugs.
And finally, number 3, remember the mechanism that makes it all work. It's those 2 levels of indirection. That separation of choice. Family first, then the specific product. That's what gives this pattern all of its flexibility and power. So, I'll leave you with this question to chew on. Think about your own projects. If you have systems with these distinct families of objects, different themes, different platforms, different providers, how are you making sure they never get mixed up? The Abstract Factory might just be the clean, robust solution you've been looking for. I really hope this helps you build better systems.